Okay, so let's do some practice with assigning intermolecular forces. So I'm going to go back to this VESPER practice that we did back towards the beginning of chapter 5. So these were the 6 molecules that we assigned molecular geometry to, we assigned polarity to, we talked about orbital hybridization, number of pi bonds, number of sigma bonds, and now we're going to add one more thing. We are going to list all of the types of intermolecular forces available for each of these molecules. So, carbon tetrachloride. So the first thing you want to see is this molecule polar or nonpolar? This is a nonpolar molecule, so the only intermolecular force are London dispersion forces. That's the only intermolecular force for carbon tetrachloride because it's nonpolar. That's the only type of intermolecular force it can have. So now let's look down here, ammonia, nitrogen trihydride. So first you want to ask, is this molecule polar or nonpolar? It's polar. So that means we have London dispersion forces, dipole-dipole interactions, and then we want to see, does it have hydrogen bonding? So remember, to have hydrogen bonding, you need to have a hydrogen that is covalently attached to a nitrogen. This hydrogen is going to be attracted to another nitrogen of another nitrogen trihydride molecule if we had a whole bunch of those molecules next to each other. So yes, this can hydrogen bond. So this has all 3 of the intermolecular forces. It has London dispersion forces, dipole-dipole interactions, and hydrogen bonding. So all 3 of the intermolecular forces there for ammonia, nitrogen trihydride. So let's look at carbon dioxide. Again, is it polar or nonpolar? It's nonpolar, which means it can only have London dispersion forces. Same for oxygen. Oxygen is nonpolar, only London dispersion forces. How about arsenic trifluoride? Well, it is polar, so it has London dispersion forces and it has dipole-dipole interactions. Does it have hydrogen bonding? No, because it does not have a hydrogen bonded to an oxygen, nitrogen, or fluorine. So it has 2 types of intermolecular forces, London dispersion forces and dipole-dipole interactions. Okay, let's look here. Here is sulfur dioxide. Sulfur dioxide is polar, so that means it has London dispersion forces and it has dipole-dipole interactions. Does it have hydrogens covalently bonded to oxygens, nitrogens, or fluorines? No. So it has 2 of our 3 possible intermolecular forces. So on the exam, you are going to be expected to be able to provide all of this information about whatever molecule I choose. So I would give you the name. You would be able to write the formula. From the formula, you would be able to draw the Lewis structure. From the Lewis structure, you could tell me the steric number, the electron geometry, and the molecular geometry. You could draw the molecular geometry, assign vectors, and tell me if it's polar or nonpolar. You could tell me the orbital hybridization, the number of sigma bonds and pi bonds, and lastly, based on that information, you could tell me the intermolecular forces. So chapters really 4, 5, and 6 really could be one huge chapter, and this one question covers almost everything from those 3 chapters. So these are really good practice problems. Definitely prepare for something like this on the exam.